0. Sorry, my screen counts down, and it's always like I'm ready for it to blast off when it gets to 0. So we are doing the last method for solving systems of equations today. So last week we did graphing and substitution. So this week we are wrapping up systems of equations by doing the method of elimination. Now, this is Monday's video, May 4th. May the 4th be with you. You are supposed to be on page 68. So right now, pause the video, write your notes, title it, all that. It's 8EE 3.8. Write the steps in the first example, and then press play once you did it. So that way I'm not taking time recording while also writing it all down. Just so that this video is not too long, because I do want to get through a decent amount of practice problems so I can help you guys as much as I can through this video, and also just because there's a lot of different ways to solve these, etc., etc. So pause the video, because the next thing I'm going to say, you should have already written this down. Pause it. Okay, so now you magically already have this all down on your paper. If you don't, you should, because you're disobeying, and you really should, because you're not helping yourself, especially for the future. Now, it was really confusing for me when I learned systems of equations, because I was like, okay, there's graphing, ew, there's substitution, and there's elimination, and like I don't really get it. Like, I get that we have these two linear equations. We have these two equations that have the same variables, and we're kind of like solving for x and y, and then it's an ordered pair as the solution, because that's where the two graphs like intersect, so that's where the equations overlap. But like, how do I know which method to use? And this wasn't part of the plan, but now I think I'm going to. I think after this video, I'm going to make a video where we just do some practice problems together, and I'll show you that honestly, you can use any of the three methods. Sometimes the equations, the system that they give you, it's just more obvious with experience which one makes sense to use. If you're like, oh, these eliminate, they cancel out, or oh, this is slope-intercept form, it's easy to graph, or you're like, oh, they already solved for a variable, I'm just going to substitute. So what I'm saying is, with experience, you'll figure out which method is the easiest for you personally. Everyone has their own preference, and it just takes practice. But regardless which method you use, whether you use graphing, elimination, or substitution, you will always get the same answer. There's one solution. No, sometimes there's no solution. Sometimes there might be more than one. But what I'm saying is, there's only one correct answer to the question. So it doesn't matter which method you use. Okay, I'm done talking. So, well, about that. Steps for solving systems of equations using elimination. So what does elimination mean? What does it mean to eliminate someone? Okay, think about that. You're in dodgeball, okay, and then Stemples throws a ball and hits Sora. Okay, she's eliminated. She's knocked out. She's out. So elimination means it cancels out. It goes away. It's out of the picture. Okay? So step 1, transform the system so that one variable cancels out. So sometimes you're not going to have to do this step. Sometimes it's already done for you, or it's just not necessary. So the first 2 or 3 problems we do, you're not going to have to do this. So sometimes you do this, sometimes you don't. It depends on what the equations are. So what it means is change the system. So change one or both of the equations so that we can cancel out one of the variables. How do we transform it? How do we change it? We transform it through multiplication. So multiply. I'm just going to write multiply as a reminder. We transform it through multiplication, which you'll see. Okay, step 2, add or subtract. So one or the other. Sometimes adding is going to work, sometimes subtracting is going to work. You'll see. Add or subtract the equations to eliminate, to cancel out one of the variables. Okay? Then we solve for the remaining variable. So like we'll solve for x or solve for y. And then we'll substitute, so we'll plug in. Substitute just means plug in the answer from step 3 into one of the original equations. We'll come back to that. And solve for the other variable. So you might read this and you're like, Miss Fry, what the heck are you talking about? I have no idea what this even means. Trust me, it'll make more sense as we keep going. Okay, so the first example we're going to do. X minus 2y equals negative 7. 3x plus 2y equals 3. So we have two equations in standard form. Could you graph these and find where they overlap? Yes, you could. That's not going to be the easiest method, but it would work. Okay, we're going to do it with elimination today. You also could figure out a way to substitute it by adding this negative 2y over there, and then you could just substitute in for x. If that doesn't make sense, that's fine right now. What I'm saying is any of the methods work. Choose which one's easiest for you and easiest given the problem. Okay. What am I doing? Okay, so right off the bat, we see that one of these is negative 2y and one of these is 2y. Okay? They're the same coefficient. I'm not talking about the sign. I don't care if one's negative, one's positive. But same variable, same coefficient. They're both y and they're both 2. Okay? So when you already have a variable and coefficient that are the same, you're not going to have to do step 1. Step 1 is already done, so don't even worry about step 1. Step 2, add or subtract the equations to eliminate one of the variables. So, I know that negative 2y plus 2y goes away. So we are going to add the equations, okay? So add like terms. We're adding vertically. So x plus 3 more x's. So this is 1x. There's an invisible 1 out front. So 1x plus 3 more x's will leave us with 4 x's. Okay? Negative 2y plus 2y. Well, negative 2 plus 2 is 0. So negative 2y's plus 2y's goes away. It cancels out. We are eliminating one of the variables. We're eliminating the y's. Okay, bring down the equal sign. Negative 7 plus 3. Negative 4. So now we just have a one-step equation. 4x equals negative 4. Okay? So we draw our line, box up the variable. How are we going to get x by itself? Well, they're touching, they're married, they're being multiplied, so we need to undo multiplication with division. Divide both sides by 4. 4 divided by 4 is 1. That leaves us with 1x, so we just write the x. Bring down the equal sign. Negative 4 divided by a positive 4 is negative 1. So x equals negative 1. Are we done? No. That's only half of our ordered pair. We also need to solve for y. So we solved for the remaining variable. We solved for x. So now we need to substitute or plug in the answer from step 3. So we need to plug in negative 1 into one of the original equations and solve for the other variable. So we need to plug in negative 1 to x for one of these equations and solve for y. It doesn't matter which equation you use. You'll get the right answer for both of them. So I'm going to choose to plug it into the x minus 2y equals negative 7 equation. I'm just deciding if I want to do my work down or if I want to work sideways. I think I'm going to go down. So the equation was x minus 2y equals negative 7. So I'm going to plug in negative 1 for the x. negative 1 minus 2y equals negative 7. Okay, so now it's a two-step equation. Draw the line, box up the variable, combine like terms. I need to get this negative 1 to the right side. So the opposite of negative 1, plus 1. I need to add 1 to both sides. Negative 1 plus 1 goes away. That leaves us with negative 2y equals negative 7 plus 1, negative 6. Okay, last step, they're being multiplied, so we need to divide by negative 2 on both sides. Y equals negative divided by a negative is a positive. 6 divided by 2 is 3. So that means our answer, you write your answer as an ordered pair, x, y, so negative 1, 3. That is the answer. That is the solution to the system of equations. Oh, darn it. Am I not zoomed out enough? I think I am. Okay. So, just to play it safe, I always plug in the solution to make sure that it's right. I don't take risks. Well, I do, okay? But what I'm saying is, like, with math problems and math tests, I'm such a perfectionist. I want to make sure I got it right. So we're going to plug this in. Remember that Glade commercial I showed you guys? We need to plug in negative 1, 3 to the equations and check that it's right. Check, is this a solution to the equations? So negative 1 is our x, 3 is our y. So I'm going to plug it in. I'm going to check my answer. So plug in negative 1 for x, negative 1 minus 2 times y. So 2 times 3 equals negative 7. Negative 1, negative 2 times positive 3 is negative 6 equals negative 7. Negative 1 minus 6 is negative 7 equals to negative 7. Good. Let's check it in the other one. So 3x, so 3 times negative 1 plus 2y, 2 times 3 equals 3. 3 times negative 1, negative 3, plus 2 times 3, plus 6 equals 3. Negative 3 plus 6 is 3 equals 3. Check, it works. So, plug it in if you want to check. Then there's no doubt in your mind if you're right or wrong. Okay, so that was our first example. All right, I'm going to flip my page so I have more room and keep on going. All right, example 2. Oh, why did I write 2? Oh, well. Example 2. Okay, so we're going to solve the system of equations. We have x plus 4y equals 1. And we have x plus 2y equals 5. Okay, so write down the example. Okay, so as soon as you look at the equation, the system, the equations, you look, do either of the variables have the same coefficient? So y has 4 and 2 out front. Is that the same? Is 4 the same as 2? No. Okay, what number's in front of x? Well, they both have an invisible 1. When it's the same coefficient, you don't have to do step 1. When it's the same coefficient, you don't need to transform the system because it's already going to cancel out. So we're to step 2. Add or subtract the equations to eliminate one of the variables. So, x plus x. So if we add the equations, will that cancel out the x's? X plus x, is x plus x 0? No, 1x plus 1x is 2x's. So it says add or subtract, so we can subtract. X minus x goes away. You have to make sure if you're going to subtract, though, you subtract each thing. 4y minus 2y leaves us with 2y. Bring down the equal sign. 1 minus 5, negative 4. Okay, so we eliminated our variable. Step 3, solve for the remaining variable. So we need to solve for y. Okay, box it up, draw the line. So they're touching, they're being multiplied, so we have to divide. Divide by 2, divide by 2. Y equals negative 4 divided by 2 is negative 2. Okay, so we solved for y. Okay, the last step, substitute. Plug in the answer from step 3 into one of the original equations and solve for the other variable. So we need to plug in negative 2 into one of the equations and solve for the variable. Don't plug it into this equation right here, because if you made a mistake, then you're just going to make more mistakes. So plug it into one of the original 2 equations and solve for x. So it doesn't matter which equation you pick. I'm just going to pick the first one. Why not? So x plus 4 times y. So 4 times negative 2, since y is negative 2, equals 1. Okay, 4 times negative 2 is negative 8. So minus 8, negative 8. You could put plus a negative 8 equals 1. Okay, so now it's just one-step equation. How are we going to get this negative 8 over there? Well, we're going to add 8 to both sides. So bring down the x, bring down the equal sign. 1 plus 8 is 9. Okay? Always write your answer as an ordered pair. The solution to a system of equations is an ordered pair. So x first, 9. Y is negative 2. So that is the answer. Now remember, you can plug this in. You can plug in 9 for x and negative 2 for y and see if it's correct. 9 plus 4 times negative 2. So 9 minus 8 equals 1? Yes. 9 plus 2 times negative 2. 9 minus 4 equals 5? Yes. Okay, you can plug it in quickly and check if it's right. So those 2 examples, we did not have to transform the system to cancel one out. We didn't have to transform it. Okay? The next ones we do, though, we're going to have to transform them. All right? You'll see some of both. It's not that scary. Don't get worried. Okay? And then the other steps will stay the same. Example 3. 6x minus 5y equals negative 25, and negative 2x minus 4y equals 14. Okay, so write down the equation and then look at it. So right off the bat for these other ones, we saw that in front of one of the variables, the coefficient, the number was the same. These both had a 1 out front. And in example 1, both the y's had a 2. Okay? The x's don't have the same number in front, and the y's don't have the same number in front. Uh-oh, what are we going to do? So, this is when you have to transform the system so that one variable cancels out. We need to multiply. We need to change one of the systems. It does not matter which one you change. Okay? How do you change it? So, this chair is so uncomfortable. Oh my goodness. Okay, so what you do is you try to make the coefficients the same. What do you mean? So, you try to make the number in front of the x's the same, or the number in front of the y's the same. Doesn't matter which one you go with. I'm just going to go with the x's because I see a 2 and a 6. And I think, okay, 12. Okay. You also could just see the 2 and the 6 and be like, oh, I could make this negative 2x into a 6x. So just watch. If we multiply this whole equation by 3, so basically we're going to change each term and multiply it by 3. You're distributing this 3 throughout for each thing, okay? That's my little distribution rainbow. So we're going to multiply each thing by 3. So that will leave us with 3 times negative 2x. What's 3 times negative 2x? Negative 6x. Okay? 3 times negative 4y. So 3 times negative 4y. 3 times negative 4. Negative 12y. Equal sign, equal sign. 3 times 14, you can obviously use your calculator. I don't expect you to know that. You might. 14 times 3 is 42. 42. Okay, so we transformed. We changed this equation, this negative 2x minus 4y equals 14, into negative 6x minus 12y equals 42. We multiplied each term by 3. Okay, now I'm going to write the other equation, the first one, underneath it. Doesn't matter if you write it underneath it or above it. And now I see that the x's both have a 6 out front. I don't care if one's negative, one's positive. They both have a 6. So now I know that I have transformed the system so that one variable cancels out. They both have a 6 out front or 6 or a negative 6. So the y's are going to cancel out. So now I need to, step 2, add or subtract the equations to eliminate one of the variables. So I have to think, am I going to add or subtract? Which one's going to make sense? Is negative 6x plus 6x 0? Negative 6 plus 6. Is negative 6 plus 6 0? Yes, so I'm going to add. Because if I subtracted, negative 6x minus 6x would be negative 12, and that wouldn't eliminate it. So negative 6x plus 6x goes away. Lovely. Negative 12y's plus a negative 5y. So negative 12y plus negative 5y. Negative 12y minus 5y. Okay, you can always use your calculator. Okay, I just know this stuff in my head. A lot of you guys might also, but you could just do negative 12y plus a negative 5y, and it'll be negative 17y. Okay, bring down the equal sign. 42 plus negative 25. So 42 minus 25 equals 17. All right, so now we have our one-step equation. Lock it up, draw the line. So they're touching, they're being multiplied, so we have to divide both sides by negative 17. Negative 17 divided by negative 17 cancels out. It's a positive 1, so it leaves us with 1y. 17 divided by negative 17, positive divided by a negative, negative. 17 divided by 17, 1. So y equals negative 1. So step 3, we solved for y. We solved for the remaining variable. Step 4, plug it in. Plug it into the original equation. So we altered this second equation and made it the negative 6x minus 12y. We altered it. We multiplied it by 3. Okay, you might make an error when you're doing that. So don't plug negative 1 into the altered, the changed equation. We plug it into one of the original equations. Okay, so plug it into one of the original equations. I'm going to plug it into the first one. So the first equation was 6x minus 5y equals negative 25. I'm going to plug in negative 1 for y. So 6x minus 5 times negative 1, oh, I'm hungry, equals negative 25. 6x, negative 5 times negative 1. Negative times a negative is a positive. 5 times 1, 5, equals negative 25. Now we have a two-step equation. Draw the line, box up the variable. We have to get this positive 5 over there. How are we going to do that? Subtract 5 from both sides. Subtract 5, subtract 5. So we bring down the 6x, the equal sign, negative 25 minus 5, negative 30. Okay, we got to get x by itself. They're being married, multiplied, so we need to divide both sides by 6. Leaves us with 1x. Negative 30 divided by 6, negative 5. Remember, write your solution as an ordered pair. So put the x first and then y. And remember, you can always plug this in and check that it's right. Just in your head, plug in negative 5 for x. Plug in negative 1 for y. So 6 times negative 5 is negative 30. Negative 5 times negative 1 is positive 5. So negative 30 plus 5 is negative 25. You can plug in negative 5 for x, negative 1 for y. So 10, wait, what? 10 plus 4, yeah, is 14. Okay, so it works. You will always know. Just plug it in. Check. Okay, so that was that example. All right. I'm kind of running out of room, so you know what? YOLO, I'm going on to my next page. Example 4. So, this one we're going to have 2x minus y equals 0. 3x minus 4y equals negative 10. So again, you see, is the number in front of either variable the same? No. So that means you need to change the equation. Okay? We need to transform it. We need to multiply. So you could decide, do you want to change the x's or do you want to change the y's? It doesn't matter. Okay? Do you want, so one has a 2x and one has a 3x. So in my head, I think, okay, I can make these both into 6x's. I would multiply this equation by 3. I would multiply this equation by 2, and they would become 6x's and canceled out. Or you might look at the y's and think, okay, this is a 1 in front, this is a 4. So if I multiplied this whole equation by 4, then that'll be a 4y, and they'll both be 4y's, and I can cancel them out. Whichever one you want to do is fine. Okay? Personally, I just kind of play around with the first number, the first term, the x's, even if that's one more step. So I'm going to do that one so I can show you that sometimes you'll decide that you're going to multiply both of them, and that's okay. So 2x minus y equals 0 and 3x minus 4y equals negative 10. Do I want to do that? Do I? I don't know. No, you know what? I'm not going to do that. I'm going to show you guys that we're going to change the y term to negative 4 so that it'll cancel out. So what do I multiply this by to make it a negative 4y? Or a 4 out front? Well, right now it's a 1, so I need to multiply it by 4. So I'm going to multiply 4 by each term. We're going to distribute 4 throughout. Okay? So 4 times 2x is 8x. 4 times negative y is negative 4y. 4 times 0 is 0. Okay, now we're just going to write the other equation. Exactly how it was, just bring it back over. So 3x minus 4y equals negative 10. Could I have changed the x's? Yes, that's fine. But this was one step where changing the x's would have been 2 steps. And I'm going to show you that sometimes you just do what you want. Okay, as long as it works, it works. So now we transformed it. That was step 1. Step 2, add or subtract to eliminate one of the variables. Okay, so we're going to eliminate the y's because they have the same number out front. So are we going to add or subtract? Well, let's think. Is negative 4 plus negative 4 0? Negative 4 plus negative 4? No, that's negative 8. So we're not going to add. Are we going to subtract? Negative 4 minus a negative 4. Negative 4 minus a negative 4. Well, when they're touching, that's a plus sign. Negative 4 plus 4 equals 0. So we're gonna subtract. 8x, and you'll know right away if you did the wrong one. If you add and then you're left with the variables, both of them, you're like, crap, I did it wrong. So then you need to subtract. If the coefficient's the same number, then one of them, then it'll go away. So you just have to decide, do you add or subtract? 8x minus 3x, 5x, negative 4y minus a negative 4y. Negative 4 minus a negative. So if you don't like doing it in your head, use your calculator. Negative 4 minus a negative 4. 0, so it cancels out. Bring down that equal sign. 0 minus a negative 10. 0 minus negative 10. 10. And that makes sense because 0 minus a negative 10, when they're touching, it's a plus sign. So 0 plus 10. Are you guys moving furniture upstairs? What are you doing? Oh, sounds like they knocked. It sounds like they were moving furniture. All right, so 5x equals 10. 5 times some number equals 10. We know it's 2. All right, so we got to divide by 5. Divide by 5. X equals 2. All right, so we solved for the remaining variable. That was step 3. Step 4, plug it in. Plug it in, plug it in. Plug it into the original equation. So don't plug it into this transformed equation right here. One of these are original equations. Does not matter which one. I'm just going to plug it into the first one. So the first equation was 2x minus y equals 0. So 2 times x. What's x? It's 2. Minus y equals 0. 2 times 2 is 4. Minus y equals 0. Okay, so you can either subtract the 4 over there or add the y. It doesn't matter. I'm going to do it the way I wouldn't do it because you guys might see it this way. So you might draw the line, lock up the variable, and be like, okay, I need to get this positive 4 over there. Positive 4. So I need to subtract it. 4 minus 4, it goes away. 0 minus 4, that's negative 4. Bring down the equal sign. There's a minus sign. That's a negative. Negative y equals negative 4. Okay, that's a negative 1 out front, guys. So divide by the negative 1, or just a negative. Divide by negative 1. Positive y equals positive 4. Or at this step right here, you could have just added y over there. 0 plus y is y, so y equals 4. So you write your solution as an ordered pair. So the solution is 2 for x, 4 for y. Remember, plug it in. You can check it. Is 2 times 2, so 4. Is 4 minus 4 0? Yes. Is 3 times 2? 3 times 2 is 6. 6 minus 4 times 4. 6 minus 4 times 4 is 16. Is 6 minus 16 negative 10? Yes. You know it's right. Okay? Now, could you have done this the other way? Yes. You could have changed the x's, but then you would have had to multiply both equations. And that's perfectly fine. I'm thinking if I want to show you guys one like that. Yeah, I will. You know what? Let's do it. Why not? Why not? This is just like get day. You guys are just getting a lot. So let's do negative 8x plus 9y equals negative 7. And let's do 2x minus 3y equals negative 5. So when you guys look at this, neither variable has the same number out front. Okay, so the coefficient for x's is different. The coefficient for y is different. Oh my goodness, I'm so silly. I'm so silly because like, this is not the problem I meant to give you guys at all. I meant to give you one where we would change both of them. Oh man, I meant to do this one instead of the last one. Okay, just, I don't like scribbling. Okay, there we go. I should wait that out, but ain't nobody got time for that. All right, we're going to do this one instead. Oh, Miss Fry. Negative 2x plus 3y equals 7. 5x, guys, I'm getting a rash right here. 5x plus 8y equals negative 2. Okay, so now, look at the numbers in front of the variables. You should notice, I'm about to change this focus because I feel like it just gets a little blurrier than I like. Ooh. Okay, so you should notice that the numbers, you should notice that the numbers in front of both variables is different, okay? Sorry, I think I'm just really hungry and tired. So that means we need to transform the equations. Now, I can't easily change 2 to become 5. And I can't easily change 5 to become 2. I can't easily multiply something by 3 and it will become 8. I can't multiply 8 and it'll become 3 easily. Those would have to involve fractions, and we don't like fractions. So, you can multiply both equations, okay? When I see this, 2 and 5, first I think of pizza, don't know why, and then I think of the number 10. All right, so how do we change this negative 2? I don't care about the sign. So how do we change the 2 to 10? Well, 2 times 5 is 10, so multiply it by 5. And then it becomes, well, we got to distribute that 5. So then it becomes 5 times negative 2x. 5 times negative 2x is, the color, okay, yeah. Negative 10x. 5 times 3y is 15y, so plus 15y. 5 times 7 is 35. Okay. What can we easily multiply 5 by and it'll become 10? 2. So now we need to distribute the 2 for the second equation. 2 times 5x. 2 times 5x is 10x. 2 times 8y is 16y. It's a positive, so it's plus 16y. Equal sign. 2 times negative 2 is negative 4. So now we have our transformed equations. Okay? So that was step 1. Transform one or both equations so that a variable will cancel out. The x's are going to cancel out because they have a 10 out front. Okay, is negative 10x plus 10x 0? Negative 10 plus 10? Is that 0? Yes. Okay, so we're going to add. Negative 10x plus 10x, 0, goes away. 15y's plus 16y's. 15y's plus 16y's is 31y. Equal sign. 35 plus a negative 4. So 35 minus 4 is 31. Oh, that's nice. All right. So we're going to draw the line, box it up. They're being multiplied, so we got to divide both sides by the coefficient, 31. 31 divided by 31 is 1y. 31 divided by 31 is 1. So y equals 1. Okay? We solved for the equation. So now we need to plug this back in. Oh my goodness, this is a long video, guys. I'm sorry. Plug this back in to one of the original equations. Okay, I just picked the first one because I do. Negative 2x plus 3y equals 7. So negative 2x plus 3 times 1 equals 7. Negative 2x plus 3 times 1 is 3 equals 7. Draw the line. Get this positive 3 over there. Subtract 3. Subtract 3. So negative 2x equals 4. They're being multiplied. Divide by negative 2. X equals negative 2. Remember to write it as an ordered pair. X first, so negative 2, 1. And you can plug this back in and check that it's right. Okay, I do that every time, and I'm a math teacher, and I still do it every time. Negative 10 plus, okay, I just did it. So the last question's really, really fast. I just want to show you something. Just so you guys can see it, so you're aware for next year. So the last one I want to show you, and we're not going to have to solve all the steps. You'll see why. So let's say we have 6x minus 3y equals 3 and 2x minus y equals 4. So neither variable has the same coefficient. Neither variable, neither letter has the same number out front. So you have to transform one. We need to multiply one. Okay, so in my immediate mind, see, like, I think Miss Stevens usually changes the y's, so she might multiply this equation by 3, so they both have 3's. I look at the x's. I'm gonna, oh, that's funny. I'm gonna multiply it by 3 so that the 2 can become 6. So you just think, which variable do I want to manipulate? I'm going to manipulate the x's. I just usually do because they're out front. I'm going to change this 2x, and I want it to become 6. So 2 times what is 6? 3. So I'm going to distribute this 3 and multiply it by each term. Okay? So I'm going to write the original equation up there for the first one, just so that we're working over here. Now let me write this new one. 3 times 2x is 6x. 3 times negative y is negative 3y. 3 times 4 is 12. Okay, so now we need to add or subtract. Well, which one do you do? Well, let's see. Is 6x plus 6x going to eliminate it? No, it's going to be 12x. So adding doesn't work, so that's when you subtract. 6x minus 6x goes away. Negative 3y minus a negative 3y. Well, negative 3 minus a negative 3. They're touching, so you add it. Negative 3 plus 3, that's 0. Cool, goes away. 3 minus 12. 3 minus 12 is negative 9. And what do we write on this side? Well, we don't have anything left, so 0. Does 0 equal negative 9? No. So that means no solution. Why is it no solution? Because, guys, if you graphed it, it would be graphed as a parallel lines, okay? The lines would be perfectly parallel, meaning they never intersect. And we know that the solution to systems of equations is when the two graphs intersect. It's the point where they graph. It's the ordered pair where they intersect. Not graph, where they intersect. So if they're parallel lines, they're never going to intersect. So that means it's no solution. So both variables cancel out. Thank you guys for sticking with me. If you stuck with me this long, you're amazing. I love you. Good luck. Don't stress. Goodbye.